Now let's talk about EVM compatible blockchains. So what are they and why are they important? Why should you know about them as a blockchain developer? Well, in the last video, we talked about the Ethereum virtual machine, or the EVM, and how it's such an important invention, and how Ethereum implements the EVM to make a blockchain that can run programs with smart contracts. And after Ethereum did this successfully, we saw the rise of many other blockchains that essentially implement the Ethereum virtual machine or some version of the Ethereum virtual machine with some differences to create what's called an EVM compatible blockchain. So they essentially create their own virtual machine that runs their own blockchain, but it's based off of the EVM. So why would you do this in the first place? Well, the whole idea is to create a brand new blockchain, and usually a cryptocurrency associated with that blockchain that makes some sort of trade-off that gives it a benefit that you can't get with Ethereum. So, for example, one of the biggest complaints about Ethereum is that, the layer one blockchain is slow, that it's expensive to use for lots of the design choices that Ethereum has made, and that essentially you could fork the EVM chain and change some settings to create a new blockchain that makes up for some of these things. Now, of course, it's always going to make a trade-off somewhere else, but they're essentially saying that they want to make a trade-off that Ethereum's not willing to make, and you can make some small sacrifice here to maybe get some scalability benefit and sacrifice for some security and vice versa. Now, what are the benefits of EVM compatible chains, and why have so many blockchains decided to copy Ethereum's model? Well, one big benefit from these ecosystem standpoint is that, you can essentially take software that's already been implemented, the EVM, where a lot of hard work is done. It doesn't take that much effort to change the software once it's been implemented, okay? So you can launch a new blockchain really fast. And part of what gives blockchains value in the first place is not just the fact that you have a blockchain running, but it's the entire network effect of the blockchains, which essentially means you don't just want to have a blockchain with a blank slate. You want to have a blockchain with lots of users and applications. And so in order to attract users, you need applications. And one of the benefits of having an EVM compatible chain is that anybody who can write programs for Ethereum can essentially take those programs and put them on top of an EVM compatible blockchain, because it runs the Ethereum virtual machine or some version of it. So if an app works on top of Ethereum, in most cases, it can be deployed to an EVM compatible blockchain with minimal changes, if any. So that's one benefit of bootstrapping these ecosystems. And you can use all the other tooling that works on Ethereum. For example, if you're not a developer and you want to go use an application, all you have to do is point your wallet to that specific EVM compatible blockchain, and it's the wallet you already know and use, maybe with Ethereum or some other EVM compatible chain. And all the wallets are going to be compatible out of the box with maybe a few small, settings changed. So, the users don't have to change their behavior that much. And also developers don't have to change their behavior that much, because if they can write an application for Ethereum, then they can write the application for the EVM compatible chain. So that means there is a huge benefit to you to learning Ethereum-based technologies as a blockchain developer, because Ethereum is the largest developer ecosystem by a large margin, okay? And you can write, smart contracts with Solidity for Ethereum. And once you can do that, then you can take those smart contracts and deploy them to dozens and dozens and dozens of other blockchain networks that implement the Ethereum virtual machine. So you get a lot of mileage out of that particular skill set that we teach you inside of this program. So there are lots of Ethereum virtual machine or EVM compatible chains out there. Some really popular ones right now are Polygon. You might have also heard this called Matic. Okay, there's a cryptocurrency associated with that. Binance Smart Chain, or BSC. There's Avalanche, and a whole lot more. And you can see a list here of EVM networks, a complete list that's, dozens and dozens of different blockchains. Okay, and not all of these are necessarily going to stick around forever. We see lots of new blockchains spin up. Some come and go, okay? But this is just a quick list of how many people have decided to, follow Ethereum's model and fork its client and make some changes so they can launch their own EVM-compatible chain. It's very, very popular. So let's look at a couple of examples. So Polygon, like I mentioned before, is a really popular EVM-compatible chain. It's a very low-cost chain, okay? The transaction fees are pretty cheap. compared to like base, layer 1 Ethereum, which we'll kind of get into layer 2 scaling solutions in another video. But for Polygon, a lot of people think of this as an Ethereum side chain, to where essentially it works like Ethereum and it kind of runs to the side so that you can go do some actions on that chain that are lower cost, but you might bridge back over to Ethereum. And that's what makes it compatible, is you can take the apps, move from one chain to another, and then do some activity on that app and then come back to the main chain. So how is Polygon different from the initial version of Ethereum? So basically, it is a proof of stake chain. All right, you can see the speed processes up to 65,000 transactions per second compared to Ethereum's initial 15 transactions per second. It is approximately 10,000 times lower cost to transact here instead of Ethereum. Okay, but it does have full EVM compatibility, which means that if you can write an application for Ethereum, you can put it on Polygon. So you might ask, like, why wouldn't you just do everything on Polygon? Why do you need Ethereum in the first place? Well, Ethereum's going to have much, much, much stronger security than something like Polygon. So, for the vast majority of use cases that have small amount of value, it doesn't matter as much to put it on something like Polygon. But for things that have much higher security needs, then you want to keep that stuff on the main Ethereum chain itself. Okay. So Polygon, and also, with Ethereum, it parts about the network effect of the applications that are on top of there. If you want to plug into other networks, then, you have that advantage on top of Ethereum. And one of the reasons you have that network effect in the first place is for the long-standing history of Ethereum and its security and the design choices that it has made to become the, secure public blockchain that, has stood the test of time. Now, Binance Smart Chain is another example of an EVM-compatible chain that has gained popularity over time. So this essentially is a fork of Ethereum with some settings changed to make it faster and cheaper to use. So one consequence of this is that it takes a lot more computational resources to run a node for Binance Smart Chain. So you'll see the node count start to decrease dramatically compared to something like Ethereum. That's kind of the trade-off, all right, which changes the decentralization and security of the network somewhat. All right, but let's look at how it's different and like Ethereum. So it is EVM compatible, like we talked about. The consensus algorithm is slightly different. It is proof of staked authority, okay? And the block time is about 3 seconds compared to about the 13 seconds that we saw with Ethereum earlier in this program. So all of the transaction fees or gas fees on Binance Smart Chain are paid in the BNB token. Okay, so not Ether. That's pretty typical across EVM compatible chains, is they use their own unique cryptocurrency to pay the fees. All right, but the big benefit here is that if you can write programs with Solidity for Ethereum, then you can also write them for Binance Smart Chain with minimal changes, if any. All right, so another EVM compatible chain that's gained quite a bit of popularity is Avalanche. Okay. So Avalanche is an EVM compatible chain that, has changed some settings, and you can see how it compares to a blockchain like Ethereum. Okay. And other Bitcoin, they have a comparison table to, Bitcoin's transactions per second, Ethereum's transactions per second. They claim infinity with subnets. Okay. But basically you can see that it has a slower transaction finality, a smaller transaction finality compared to the other chains. Which basically means that it's a little bit faster to use. So it's also a little bit cheaper to use as well. Okay. And it also runs proof of stake. So Avalanche is definitely another popular EVM compatible option. Okay. And if you can write dApps for Ethereum, then you can write them for Avalanche. So how can you use Ethereum virtual machine or EVM compatible chains? Well, again, as a non-developer, that's what makes it really nice, is all you have to do is connect an Ethereum wallet to it and change the endpoint to the wallet and point it to that chain. So if you have an Ethereum wallet already installed and you can use Ethereum, you can use an EVM compatible chain with a few clicks of a button. That's one of the reasons they're so popular. Now, as a developer, really all you have to do is take your project, and whenever you deploy it, instead of deploying it to Ethereum or a test network, you can just point it straight to an Ethereum virtual machine compatible or EVM compatible blockchain by getting access to an EVM compatible blockchain node. So let's say, for example, if you want to deploy to Polygon, all right, you just go into your project and you tell it the settings on how you want to point your project to Polygon, and you just run the same deployment script with a different endpoint. Okay. So that's really abstract right now without showing you an example. But later on in the program, whenever we start building the capstone project, once we finish, we're going to deploy to Ethereum, and then we're also going to deploy to Ethereum compatible chains or EVM compatible chains, so that you can see how easy it is to take the exact same application and put it on Ethereum, put it on any of these different blockchains, so that you can get a ton of mileage out of one programming language and a robust set of skills. So with that being said, let's jump in the next video.